The valves act together in the system, but their operation can be considered separately. The primary regulating valve has a number of lands, including one larger land which provides a differential area. A central stem locates the regulating spring. Fluid from the pump can act on the valve through a 1 mm diameter orifice in the circuit. With the valve at rest, the two central lands block the flow of fluid across their valleys. The spring end of the valve is subject to throttle pressure through a circuit connection from the throttle valve. The lower end is subject to modulator pressure acting on the lower face of the bottom land. A vent between the two uppermost lands prevents hydraulic lockups due to fluid seeping into the valley between them. In operation, fluid from the pump enters the valve through the orifice and acts against the differential area. As pressure rises, the valve moves upwards against its spring. Excess fluid can then pass across the two large valleys to the ports in line with them. The result is an initial regulation of line pressure at idling speed. This line pressure is directed to the manual valve and the throttle valve at all times. When D is selected, line pressure is also directed to the front clutch, to the 1-2 shift valve, and to the governor. Excess fluid passing across the valleys is directed to the secondary regulating valve and the converter. Fluid from the lower port of the primary regulator valve acts on the end face of the secondary regulating valve. This raises it against its spring. Valve movement uncovers a port to the lubrication circuit for the rear end of the gear train, and then an exhaust port leading back to the pump inlet. The exhaust bleed-off stabilizes fluid pressure in the lubrication and converter circuits within acceptable limits, from 100 to 200 kilopascals.